Okay, let's go. Redox reactions. Now we've come across redox reactions before. You'll remember that when we did electrolysis, we talked about the gain and loss of electrons. And we had our mnemonic, didn't we, which was oil rig. Oxidation is a loss of electrons and reduction is a gain of electrons. So the word redox comes from reduction and oxidation. Now, without you realizing it, most of the reactions you've come across over the last few years have actually been redox reactions. So essentially, there's been a change of electrons within the species involved in the reactions. So we need to kind of lay out some definitions for oxidation and reduction reactions. Historically, it was about oxygen, as oxidation, the word implies. Oxidation was considered to be a gain of oxygen. So when something, typically a metal, reacted with oxygen, it burns, it produces an oxide. So magnesium would gain oxygen and become magnesium oxide. The magnesium in this case has been oxidized. Okay, so the opposite also is true, that if something loses oxygen, then reduction takes place. If I react zinc oxide with carbon, then the carbon takes the oxygen from the zinc and zinc becomes zinc metal. So the zinc oxide has been reduced, it's lost its oxygen. So oxidation is a gain of oxygen, reduction is a loss of oxygen. We've talked about electrons in electrolysis. So for example, if they are lost during the electrolysis process, then oxidation has taken place. Oil rig. So oxidation is a loss of electrons. So for example, chloride ions, two chloride ions would lose one electron each to become chlorine atoms at first, and then they would make chlorine molecules to look for stability. So the chloride ion has been oxidized. This typically happens, where does this happen? In electrolysis, it happens at the anode. At the cathode, species that migrate, that are attracted to the cathode, receive electrons and they are reduced because reduction is a gain of electrons. So copper ions receiving 2 electrons to make copper metal is reduction. The Cu2+ has been reduced. There are 2 other ways of thinking about oxidation and reduction. We're not going to go into too many details, but they'll come up later on in the course. Hydrogen is considered to be a loss of hydrogen. Oxidation is considered to be a loss of hydrogen, and reduction is considered to be a gain of hydrogen. Now that's actually quite easy to remember because it's the opposite of with oxygen. So oxidation is a gain of oxygen, oxidation is a loss of hydrogen. Reduction is a loss of oxygen, reduction is a gain of hydrogen. It's exactly the opposite. And the other thing, which we'll come across in a few minutes, oxidation state, which you haven't heard of before. If you increase the oxidation state, it's oxidation, and if it decreases, it's reduction. Okay, oxidizing and reducing agents, sometimes called oxidants and reductants. If a substance oxidizes another substance, then it's called an oxidizing agent, sometimes oxidant. For example, if we've got chlorine reacting with sodium bromide, then what happens is the chlorine kicks the bromide out of the sodium bromide to become bromine molecules. It's bromine as an element. So it goes from Br-, goes from bromide ions to bromine as an element, and the chloride ions take its place in the substance. Here we've got Br minus becoming Br2. The Br minus, the bromide ions, have lost electrons. Loss of electrons is oxidation, so they've been oxidized by the chlorine. The chlorine here is the oxidizing agent. If the first substance reduces the second substance, then the first substance is called the reducing agent. Here's a good example of that from the production of iron. Carbon monoxide here takes oxygen from the iron 3 oxide. The carbon monoxide takes its oxygen away. Reduction is a loss of oxygen. So here the iron 3 oxide has been reduced. So in this case, the iron has gone from being Fe3 plus to Fe. It has gained electrons, and so it's been reduced by the carbon monoxide. The carbon monoxide is the reducing agent. Okay, a couple of examples for you to work on. Lead 2 oxide and carbon, and they produce lead and carbon monoxide. So lead 2 oxide and carbon, if we heat them strongly, the lead loses its oxygen and carbon becomes carbon monoxide. You can start to imagine what's happening here. Now, if lead oxide has gone to being lead, then it's lost oxygen and it's been reduced. If carbon has gone to being carbon monoxide, then it's gained oxygen and it's been oxidized. So now we have to identify the oxidizing agents and the reducing agents. The carbon has reduced the lead oxide, so the carbon is the reducing agent. The lead oxide, the opposite is also true, isn't it? The lead oxide has oxidized the carbon, so the lead oxide is the oxidizing agent. Let's try another example. If magnesium reacts with copper sulfate, you know from key stage 3 that this is a displacement reaction. The magnesium takes the place of the copper in the compound and copper is deposited. So the magnesium has lost electrons to become Mg2+, so it's been oxidized. And the copper 2+ has gained electrons, so it's become copper and it's been reduced. Think about that. Magnesium has lost electrons, oxidation is a loss of electrons. Copper has gained electrons, reduction is a gain of electrons. So the magnesium here is the reducing agent because the copper has been reduced by the magnesium. And the copper 2 sulfate is the oxidizing agent. So let's make sure we get this the right way around. The magnesium has been oxidized, so it is the reducing agent. The copper has been reduced, so it is the oxidizing agent. I want to leave you with this last example. If you react copper to oxide and hydrogen, the reaction produces copper and water. Write out the reaction and try and work out which is the oxidizing agent and which is the reducing agent.